So 7.1, we're talking about trigonometric functions. So we're starting trig. Just talking about our basic trigonometric functions. We'll go sine, cosine, tangent, and then actually we're going to add a couple that you probably haven't seen before. And that would be secant, cosecant, and cotangent. So these are the things that we're going to be talking about. I don't know if I really use the word cofunction, but I think that our new curriculum Envision does. So these are things we're going to do. Ms. Duel made this fantastic slideshow, and so I couldn't pass it up. It was too well done, so we're going to use it. So here we go. If you were forgetting how this whole deal works, and we're looking at trigonometric ratios, right? We look at them in terms of the sides of a right triangle and some angle theta. And right, maybe it's been a little while. It wasn't on your vocabulary list, but I think that this is very important. Many people are like, Mr. Dorman, what is the circle with a line through it? This is theta. It normally represents an unknown angle measure. Uncone? No. Unknown. Unknown angle measure. Oh my goodness, come on. Never written before. There we go. Oh, and I never checked this. You can hear me fine. I'm sure I can. Oh, nope. I'll advance this a little bit while I'm messing with this. All right. So I feel like making this smaller so that y'all can see this all at once. There you go. That's a more complete picture. And those are all extremely important things to know, especially these trig ratios, that sine theta is opposite over hypotenuse, that cosine theta is adjacent over hypotenuse, tangent theta is opposite over adjacent. And now we've added cosecant. I think these are things that maybe you didn't see in geometry. Cosecant, secant, and cotangent. They're just different trig ratios. Let me see if this. No. Let's connect. I don't need to set this up. What? Yes, I had it. And beautiful. Cool. All right, sorry, my headphone decided to do something weird. Now we're good. Probably sounds a lot better too. I know that the mic on this computer is awful. Do you guys need me to zoom in on that, make it bigger or something like that? I see a lot of people swimming. Sorry. Let me fix that for you. You just need, as long as you have this triangle, right? I want both of them there because it doesn't make sense, without the triangle. So, but there you go. People extremely excited. Spring break is like what, next week? Yeah. Oh yeah. And I got my last dose of my vaccination on Friday, so it's gonna be a pretty good spring break. I might even be among people. We'll see. Oh man. Ooh, they brought a second cop. That's never good, by the way, folks. If you get pulled over and a second police officer shows up, they're gonna be there for a while and possibly become searched. But I mean, if you didn't do anything wrong, then it's not a terrible thing. It's just time consuming and annoying. And maybe a violation of your Fourth Amendment rights. But it all depends on how good the police officer is. All right. Just checking in to make sure everyone's got those ratios written down. You gotta have those notes somewhere. Very important. You'll write them down sooner or later, so I'm just taking a nice pause for everyone to get that stuff down. All half of the class. Okay. All right. I think we're ready to move forward. Okay. Or maybe I should ask you to look at the ring. When okay, here we go. And here they are again. Oh my gosh, what a much better picture. But let's go ahead and actually write these. Okay, let's actually write these. So our opposite, right, is here, and it is interesting. I'm just trying to talk about, you have your opposite written here, right, and you have your adjacent written. And oftentimes it's difficult to realize which is which, right? I think maybe as we go through a few of these, it'll become clear. Hypotenuse always, right, is opposite your right angle, right? That's quite easy. And then if theta, right, so theta is here, yeah, and we'll talk about it. Then adjacent is going to be the one closest to theta, right? And opposite is opposite of theta. Okay. So look for where theta is. Look for theta, right? And then just go straight across to find opposite. Look for your right angle, straight across for your hypotenuse. And the other one is your adjacent angle. So these are pointed out for us. So we can quickly write these things in, right? So our opposite is 21, hypotenuse 29. For cosine, right? It's adjacent over hypotenuse, which is going to be 20 over 29. Tangent is opposite over adjacent, or 21 over 20. Cosecant is hypotenuse over opposite. And then hypotenuse for secant theta is hypotenuse over adjacent, or 29 over 20. Cotangent is adjacent over opposite, or 20 over 21. Oh, brother. Yeah. They brought another cop. You know, I mean, this brings me to a good piece of advice, right? When police officers tell you to do something, you should probably just do it. Just do it. Like, maybe you don't agree with them. That sucks, right? And maybe, but you should just do what they say. They have guns. No, just kidding. Just because, it just makes life easier. You don't have to sit here for half an hour getting hassled. All right. Okay. I feel like we've just done this. And we've been given all of these things. And here's the answer to that, but we don't really need to mess with that too much. Okay, now. Here we go. Now we're going to get into something a little better, right? If we know that tangent theta is 15 over 8, right? We could learn all of the other trigonometric ratios for theta just by using this information, all right? So, and this is why I was like, I could have easily done this from home. Nobody else is here, so I have no students today. I know you guys are not really in that boat because you haven't been on campus really yet for school. But yeah, everyone is home today, including the teachers, except for me. For some reason, I drug my sorry self up here. No, I'm not sorry. It was good. I wanted to go for a bike ride this morning. All right, so the first thing that we need to do is use this definition to find out that the opposite, right? So remember, if we go straight across here, right? This is my hypotenuse, right? Straight across from my right angle. And then my opposite, right, is directly across from theta. So, this is my opposite. And I think that this is something that needs to be established, before you start writing. And that means that the last remaining one is the adjacent, okay? So now, with that information, we're able to put the opposite there and the adjacent there. We've got the good old-fashioned Pythagorean theorem will tell us the length of the hypotenuse. I was going to say measure, but there are no units here, so we're not measuring anything. It's just a length. So after we go through the Pythagorean theorem, oh my goodness gracious. Once we go through the Pythagorean theorem, we'll find out that we have a length for our hypotenuse. And after that, we can do all of these 6 trigonometric ratios because they're just ratios of either your hypotenuse adjacent or your opposite. I could remember the last. So now that we know all of our different side lengths, we can come up with each of our trigonometric ratios, which we will do right now. So, and honestly, when I do this, I will write down what opposite and adjacent are. I'll write these things so that I can keep track, right? The hypotenuse is obvious, right? But adjacent and opposite could be easy to get mixed up. So I actually write which one adjacent and opposite is, unless I've been doing trig really a lot and I'm super used to it. But I do trig once a year. So it's been about a year since I've done any trig, except for maybe tutoring some students here and there. My specialty is statistics, so do a lot of that. All right, and I think I got all those right. Hey, more friends came. Sweet. Hi, friends. Let's see how our friend over here in the pickup truck is doing. Have they gotten him out of the vehicle yet? I think that's the issue. I think that he is refusing to exit. It's quite possible. Quite possible. I think he would already be out of the car. Maybe. Maybe. Yeah, who knows? Who even knows? Let's see. Cool. And just while people are still writing a few notes, I'll be probably starting to work on your retakes grading or getting them in today. So, and I'll also have a look and see if anything extra got turned in, which is really fun because the way that I do that is I just put two lists of grades right next to each other and see if anything's changed from one to the other. It kind of hurts my eyes. But it's all right. Okay, cool. Looks like everyone's got that. All right. Next. So let's figure out what the trigonometric ratios of this are. So remember that sine is opposite over hypotenuse. And my goodness, how could I have done this whole thing and never talked about SOHCAHTOA? You guys have probably learned this. Oh my goodness, this should have been all the way at the front of the lesson, everyone. But you guys have seen it, right? I really hope so. Thing is you're not going to have to memorize this because means that sine is opposite over hypotenuse and cosine is adjacent over hypotenuse and tangent is opposite over adjacent. It just gives you the first two, and then you'll see that cosecant is the reciprocal. If I can spell, which you guys have probably established. Can't. Okay. Each one of those is going to be the reciprocal of the other, right? So these three new trig functions or trig ratios that we have introduced are just reciprocals of the others. You just have to remember cosecant goes with sine and secant goes with cosine. Cotangent is easy to do. All right, so now with that out of the way, right? This is our opposite then. So opposite goes here. It's already written for us. So opposite is 24. Adjacent is 25. And using that information, we can fill in. Oh, no, we can't fill it in yet because we're missing the hypotenuse. And I'm going to go ahead and erase SOHCAHTOA. Because we're going to have to do some. All right, we got a squared plus b squared equals, and that's what we really want to know. We need to know what is our hypotenuse. Well, 25 squared is 625. And 24 times 24 is 576. All right, we're going to add those two together. And we get 1,201. And then we take the square root. And we're going to get about 34.655. Yucky. Everything's right there. Oh, I thought they would have given a nicer one. Well, they didn't. All right, and so we can put a decimal in there. That's fair game. So that means that's 24 over 34.655. 25. This one is going to be 24 over 25. 34.655 here. Divided by our opposite, which was 24. And so there you go. We filled them all in. Not too bad, right? Let's see. Can I see? All right. All right, good to go. Yeah, no, good. Okay, cool. All right. Here we go. Nothing like a math problem with a fire truck in it. Okay. I think. Oof. Okay, we need to go faster. Okay. We are going to need to, well, we have a diagram sketched for the situation. Oh, we are just being explained how to do this one. All right, so let's read the problem. Fire truck has an 84-foot ladder extended against the building, forming a 55-degree angle with the top of the truck. The truck is 8 feet tall. The firefighters are trying to reach a window that is 75 feet above the ground. Will they be able to reach the window using the ladder set at this angle? Well, let's see. So here's a diagram that looks a lot like that, right? And then information missing from the picture was right that we had that 8 feet that was missing there. All right. So, and also, not only do we need to decide what trigonometric function we want to use, we need to decide where theta is as well, right? So, guys, theta is going to be, oops, where is theta? Oh, my bad. How are they doing it? I have to actually make sure that I don't decide a different value of theta than they do. Is that yeah, so theta is 55. So they're deciding. 55 is theta. It's probably been maybe a minute, or maybe you never have solved for x in this case, right? Okay. So they're saying solve for x. Well, what we're doing here to get from here to here is multiplying both sides by 84, right? Then those cancel. And you're like, well, how do we get this value from that? And the answer would be getting out your handy dandy calculator. So let's go ahead and do that. They wrote that guy a ticket and let him go. Let me get this down. Some important things to keep in mind. And sorry, I know I stopped presenting, and that is because I'm going to show you. Okay. So the value we're looking for is 84 sine 55. And this is a good time to test your calculator and make sure that it is in the correct mode. We'll see if mine is right now. So your sine button is right here. And we're doing sine of 55. And hit enter. Okay, so I got something very different from what we got here in our answer. In fact, a weird thing, I got a negative angle measure. If you wound up getting the same thing, then what we need to do is we need to go into our mode section, our mode, I don't know, place in our calculator, and we need to switch it to degrees. It's in radians right now. We need to switch it to degrees. Now that we are in degrees, if I hit second, quit, and I have to go back and enter the same thing, I will get the correct answer, okay? So please do make sure that your calculator is set to degrees right now because we're measuring degrees. So the way to know, right, would be if I'm taking sine of a angle measure, 55 degrees, 65 degrees, something like that, right? Then my calculator is going to need to be in degree mode, or else I will get the wrong answer. We'll get something weird, right? So make sure that your calculators on your Chromebooks have been set to degrees. Okay, so that's how we get that value of 68. And so we just need to add the extra 8 feet. And it looks like the ladder extends beyond 75 feet. And we're good to go. All right, moving on. Cool. All right. Okay, we've got a 60-degree angle to the ground. How long is the shadow cast by a 20-foot flagpole? All right, I'm going to start this one from beginning. All All right. So obviously, if it's a flagpole, there's a right angle here, right? We would like to know how long that is, right? We know it's a 60-degree angle to the ground, so we know that this is 60 degrees, which means that we're going to use this as our opposite. This is adjacent. I don't know if we need it or not, but figure we'll write it down to get used to it. So we will need to know how long that is. We know that this is 20 feet. Cool. Just filling in some information in the picture, right? It's a really great thing to do. Before I even begin trying to think about how to do the problem, I always write down stuff that I don't have to think too much about, right? I don't have to think about how to solve the problem when I'm just trying to figure out what basic stuff is, like opposite, hypotenuse. Where do all these numbers go, right? And then I'll try to figure out what I need to do to solve the problem, right? I like to try to get things started with stuff that's a little bit easier to think about. That way my brain feels accomplished before beginning. I don't know. It makes me feel like I did something. Like, look, there's more to look at. I feel confident, right? Or more confident. So let's go ahead and we could use any of these trigonometric ratios. What is our, do we know our hypotenuse? No, we don't. Should we go? We need adjacent. So we should probably have opposite over adjacent, right? So if this is what we need, right? I'm going to write, if I try to do sine, right? What is sine? So, it's opposite over hypotenuse, right? Well, I need something that has adjacent and opposite in it, right? And so that's why I'm going to go ahead and choose tangent theta. Okay, so we're going to look at tangent of 60 degrees. Because that, right? Toa, soka, toa, right? Toa, so tangent is, remember it's the toa, so that means tangent is opposite over adjacent. Which is what we really want. I mean, I guess I could have used cotangent, and then I wouldn't have to flip it. It would take me one less step just thinking ahead. So I'm actually going to show you. So I'll write this one down, and I'm going to choose to do cotangent because it's going to be less work. So this is the thing we're looking for, right? We're looking for adjacent, right? And remember that was opposite over adjacent. Now we could multiply both sides by x and divide both sides by tangent 60, I guess, if we wanted to. I'm just going to do that, actually, because we have a tangent button on our calculator. Should I? Yeah, I don't want to access the other trig functions. Let's do it this way. All right, so it's kind of weird, right? I got the long way to do it would be to multiply both sides by x. I get x tangent 60 degrees equals 20, right? Because the x's are going to cancel. But now I need the x by itself. So I'll divide both sides by tangent of 60 degrees. And that tells us that that's what x is. X is 20 divided by tangent of 60 degrees, which we should be able to put into our handy dandy calculator. Just give me one moment to get the proper screen up for that. Okay. 20 divided by tangent of, good grief, I forgot the angle measure, 60 degrees. and we get approximately 11.547. Don't worry, I'll put that back up here in just a moment. There you go. There, sorry guys, there you go. I really thought that there would be a lot more teachers here today. I guess they don't like to be here. They like to be here. All right, ready to move on to the next one? Sorry, weird noise. Cool. Awesome, thank you. Here we go. Oh my gosh, what have I done? Feet. I did not include units. I technically got it wrong. Wouldn't be the first time. Okie dokie. Here we go. Gosh, are we like down? There, oh my goodness gracious. All right. So we've got a 45, 45, 90 triangle. This is a special triangle. OM is length 2. And we need to find 6 trigonometric ratios for angle N with measure theta. Okay, so lovely, we've been given that picture that's on the left-hand side. And then using the Pythagorean theorem, we can fill in some missing information, right? We can fill in information about the hypotenuse. Also using the idea that, check it out, if that's a 45, 45, 90 angle or triangle, right? That is an isosceles triangle, right? And meaning that 2 of the sides are the same. Any triangle that has, maybe remembering from, in this case, that I swear that's a right angle, okay? If these 2 angles are the same, right, if this is X and this is also X, right, then it must be the case that this is A and this is A and this is B, right, that these are equivalent. If these 2 angles are equivalent, these 2 sides must be equivalent. The only way for those 2 angles to be equivalent is if they're 45-degree angles, because this one is 90 degrees. So it's a special triangle. It is an isosceles right triangle. All right. I taught geometry for it was kind of fun. Sophomores are much better than freshmen. It's amazing what either can do for a human being. Well, once we found all that out, we can just fill in the trig ratios, right? All right, so let's go ahead and bust one out real quick. Let's see if, I mean, really the information that you really need is it's just kind of the original setup for the problem, right? All the trig ratios are fairly easy to fill in after that point, right? Okay, we're going to keep going. So in this case, we have a 30, 60, 90 triangle. In that case, guys, remember, in the 30, 60, 90, special triangle, a little special triangle rule action going on real quick. If this is theta, well, we don't really need to know theta in this case, because it's going to have to be, my bad, I don't want to write theta there. I want to write, so that's 90. And that means that this is 30 degrees, and that means this is 60 degrees, okay? So your hypotenuse will be twice as long. Man, I wish that that was here. Let's see. I'm trying to see if in the setup of the problem you're going to be given what you're going to be given. So you're only given this. So in this case, if this is x, I'm having a little down. I'm almost okay. And then you can figure out your remaining side. Yeah. And then this would be unknown. But we know that that's how they got 8. And I think that's really the information that's missing from this problem. The rest, I think you all are able to figure out fairly easily on your own, right? Especially, from here down. We've already done that problem, right? The thing that we're missing is how do you get your missing side lengths if you have this special triangle that is a 30, 60. Okay. It's a long lesson, guys. All right, so let's go ahead and do one real quick. So this is an isosceles right triangle, promise, even though I draw quite poorly. The length of the hypotenuse is 5 root 2. What are the sine and secant ratios for a 45-degree angle? So let's just call this one theta. So we need to figure out what these two are. We know that they are the same, okay? We know they're the same. So in other words, if I was going to go a squared plus b squared equals c squared, right? Well, a and b are the same, right? So I can just say that a squared plus a squared is equal to, and in this case, c squared is 5 root 2 squared. And so if I add those together, I get 2a squared. And then when we square this, we're going to square each thing separately. So that's going to be 25 times 2. So 2a squared, 2a squared is 50. We'll divide both sides by 2. Take the square root of both sides. Remember, since we're dealing with triangles and side lengths, we don't need to consider both positive and negative values for this square root, because negative values don't exist, right? There's no such thing as a negative side length. Not in our universe. Or at least our known universe. Who's to say what we don't know? All we can know is what we know. We can never know what we don't know. Sorry, got way too deep there. Anyhow, that means that this is 5 and this is 5, right? And so if we chose this 45-degree angle here to be theta, then let's go ahead and decide which is opposite and which is, oh no, wait, what? That is, oh no, I don't know why I thought we went to 820. What did we miss? No, we're good. All right, guys, I will post a video with the last example on it for you guys. All right. Thank you for being here today. Take care of yourself. It's going to be a nice sunny day. Put some sun on your skin today. In other words, go outside. Bye.